Welcome to the scenario Active Directory Forest Compromise. Welcome everyone to another scenario video. In this scenario video, we are actually going to be flexing our RTFM skill sets, running some DS queries, and eventually compromising the parent domain and the Huntsville child domain. If you remember from our last scenario video, we were able to jump over to a Chicago workstation that we saw was assigned to an AI intern. We data mined that machine and we found a welcome letter that referenced a developer over in the Huntsville domain that was in charge of some of their AI development. Now that definitely fits into our mission. Cyber Inc. hired us to go see what types of protections were in place for their AI development source code. So we're gonna go ahead, we're gonna pull that thread, and we're gonna see if we can get over to the Huntsville domain. Now there will be some bumps along the way. Child domain controllers typically do not have administrative access to their parents. So we're actually gonna have to try to find some misconfiguration, some way to access that parent domain controller. That way we can go ahead and move down to Huntsville. So I have our Sliver sessions up over here. I figured it would be a good opportunity to talk through all of our Sliver sessions and do a very quick overview of what machines we've already compromised and the why. I did clean them up a little bit. I don't know if you remember, we had the file server we had compromised and a couple others. But like I said, I kind of brought it down to a little bit more minimal list so we're not overwhelmed with a bunch of extra sessions. The first thing you'll see here is in the Chicago domain, we have a user, Phyllis Snyder. She was actually the person that clicked our initial access executable. So she was the first session we got here. And then we data mined the file server and we eventually found all those user home directories were saved to a share that was set to read all. So we were able to go in there, read everyone's home profile directory. And it was through that we discovered one of the domain administrators was copying their passwords to a spreadsheet and then copying it to their home directory. They probably thought it was permissioned appropriately and no one else would gain access to that, but that's why we're here, right? We gained access to that password, we escalated in the domain, we compromised the domain controller, and then once access to the domain controller was secured, we ended up running DC sync to copy passwords from the domain controller back to our attack box. And then the last step we took was we actually compromised two additional workstations, this Chai WS04 and this Chai WS11. Now there were a couple reasons. A, we wanted to get on that AI intern's workstation. Awesome, mission accomplished. But B, we also wanted to fortify our access to this domain. That way, if network defenders were to block our access, we could easily pivot to some of our other workstations that are beaconing out and further our operations. So that's where we're at now. We have the DC here. We have a few workstation accesses, but now let's go ahead. Let's start to enumerate what that parent domain controller looks like. Maybe start to assemble a playbook of the different host names and other things we need to have. And then hopefully we can find a way to try to gain access. Now we do have two domain controller accesses here. For some reason, this one ended up being an HTTP beacon. We talked about how that's an extremely bad idea. Administrators don't typically surf the internet from a domain controller. So whenever possible, please use an SMB beacon or some type of reverse TCP connection if you have to. So we're gonna interact with this session right here. Let's do our sessions, TAC I, paste it in, excellent. And then we'll do a PS, make sure it's alive and kicking. We'll drop down into our shell here, do a little task list. Awesome. So it looks like our domain controller session's working well. I think I've mentioned it before. Sometimes these remote access tools will just be intermittent. You might have a connection just crash. So it's always a good idea to issue just a random command, something safe, to make sure the session's actually live. Now, like I said, we are going to be running a bunch of commands out of the RTFM. Let me copy this first one right here, this DS query command, and then let's talk through kind of why I'm running this as my first command. So this DS query command is going to dump out trusts that are in relationship to this current domain. So let's fire it off here. So we're gonna make sure we only return any objects that are a trusted domain object. And then we're specifically asking for the attributes flat name, which is gonna be the target domain name, and the trust direction. Again, trust direction of 1, best case scenario, that means we can access their domain. Trust direction of 2 is the opposite. They can access our domain. And then a trust direction of 3 is kind of a dual way trust. We can log into their environment, they can log into our environment. So we have our domain here, Cyber Inc., and a trust direction of 3. That's great. That means we should be able to query into their target domain, and that means they can query into our target domain. Because I have access to start to enumerate that target domain, you're gonna see me using this TAC D option a lot. This TAC D option basically passes in the domain that you wanna execute the DS query at. So we're going to be using the TACD option. The first thing I'd like to do is actually dump out some computers in Cyber Inc. if I can. So let's paste this one in our playbook here and just kind of read over it. We're going to say object class equals computer. Please return all the computers. And then attributes, give me the name, DNS host name, operating system, description, and then don't forget we need that TACD option to specify the target domain. So we're going to do TACD Cyber Inc. Let's copy this one up here. We'll paste it in. So we got our results here. We have one lonely computer in the Cyber Inc. domain. Now, this isn't necessarily uncommon. The parent domain is kind of more managerial, so you may not see a ton of workstations and other resources up in that domain. So this isn't a huge deal. We're gonna go ahead and copy this because we want access to this data later. So we're gonna copy this, paste it in, and then if we need that host name, if we need the fully qualified domain name, we have it. This is where the misconfiguration and potentially gaining access to that target parent domain comes in. Like I said, if we grab the domain administrator in our Chicago domain, that will not give us administrative access to the parent. We may be able to enumerate Active Directory objects with that credential, but that doesn't mean we have local administrator to the domain controller. That messed me up for so long. I was like, oh, there's a trust available. Awesome, I'll just grab a DA and just go compromise that box. But not quite. That's not how it works. We can actually list out local administrators on the parent domain controller, and you're not going to see the Chicago domain admin group in it. So at this point, you may spend days, you may spend weeks trying to enumerate that target domain, trying to gain access. Now I'm going to speed that process up so you don't see me just running stuff for hours here. So let's start to enumerate that CyberInc domain controller, and we'll see if we start to find the vulnerability I put in place. So one of the common DS queries you're going to run is this admin count one. I love it. It's casting a really wide net to try to find any administrators in a target domain. So we're going to do a TACD option here, which means remote domain. We're going to give it Cyber Inc. And then this query is just basically going to say return all objects that are users and have an admin count equal to 1. Again, this is like a Boolean value that gets set to 1 when an account gets some type of administrative flag associated with it. So let's copy this DS query. We'll paste it in here, fire it off. So we just cast a really wide net. We just have the users back we're interested in. I'm going to copy these out with the query name here. Again, it's a lot easier to kind of interrogate and check out the data when it's in a notepad than when it's kind of flooded in a session callback window. Now we have a lot of options forward. Like I said, this could take days, this could take weeks, but one of these names should kind of stick out to you. One really common way to try to gain access to target domains in some type of forest setup is to see if you have multiple users and multiple domains that could share the same password. And more specifically, it may be an actual user that uses the same password everywhere. This is a great common technique to try. You never know if it's going to work. So we're actually going to do some queries here. We're going to go through the whole list of users, trying to see if any of these users exist in our Chicago domain. Again, they don't need to have domain admin creds. They don't need to have anything specific. We just want to see if they have a user account that we could potentially steal the hash of and then try to replay it, reuse it for the target domain. So let's see if we can find any of these users. So I'm going to go ahead and try Kara here. Let's go ahead and copy Kara. And then we're going to craft a DS query to look for all users that have Kara as the first name. I would also do a DS query looking for that last name as well. You never know what it's going to hit on. So we'll do a DS query star, TAC filter, name equals star, and then I believe it was Kara, star. Attributes, give me the name, SAM account name, fire that off. Again, we're looking in the Chicago domain. You did not see me use the TACD option here. And here we go right here. Things are starting to align. We know Kara has an enterprise admin account in Cyber Inc. because we remotely enumerated that. She also has an individual user account here in Chicago. Again, we are not going to try her Chicago account to see if it has access to Cyber Inc. That's just not going to work. It's a basic user. However, we can try to see if she's a bad user and set the same password in Chicago and in Cyber Inc. on her enterprise admin account. So let's copy this. This is another thing we want to save off to our playbook here because this is a potential solution. Again, it may not work, right? You may perform all this research, it doesn't work, and then it's back to the drawing board to look for other misconfigurations or vulnerabilities. We do need Kara's NTLM hash. However, if you'll remember, we were using some Mimikatz before to do DC sync. So let me search for that right here. Let's see if we can find the DC sync Mimikatz command. Looks like right here. Perfect. We'll copy that out to our playbook, and then we'll start to update the fields. First things first, let's make sure Mimikatz is still up here. I think I put it, yep, mimi.exe right here. That's exactly what we're going to be using. Let's bounce back to our playbook. So we're going to say c mimi.exe, and then we're going to do LSA dump DC sync. The domain has to be the fully qualified domain name. So we're going to do chicago.cyberinc.local. And then we have this whack username. We want to make sure we plug in Kara's account right here. So we're going to do kara.vasquez. Again, don't get confused here. We're trying to get the password hash for that basic user account in Chicago because that's the domain controller that we're currently sitting on. We do not want to put the enterprise admin account here. Chicago has no idea what that password hash is. So we have Kara's account right here. Let's go ahead and try to run it. Paste it in here. Awesome, we got all the hashes here. Let's go ahead and grab the NTLM hash. We'll bring it back over here. And I hope you see the importance of having a playbook. I'm just kind of adding some of the evidences, some of the things over here that I need as I progress through this technique. Let's go ahead and run our exit on Mimikatz over here. I probably should have put that at the end. Now that we have a password for that basic account, we're gonna try to forge a token using that same hash and the same password for the enterprise admin account. So let's come up here, let's grab the actual account, same account name right here. We'll copy that down to the bottom of our playbook so we can play off that a little bit. We are gonna need the pass the hash Mimikatz command. So let's jump back to the RTFM and grab that real quick right here. Copy, paste it in at the bottom of our playbook. Now we can start to plug in some of our variables here. So we need to fill in the username. The domain, generally I stay away from FQDN if I can. So we're gonna do Cyber Inc. The hash is gonna be this NTLM hash right here. And then you see me use it before. We're gonna do C Windows System32 upnpcont.exe. And then finally exit right here to exit the Mimikatz console. Let's update the beginning of it right here with our C mimi.exe. Now again, in the real world, you would probably use Mimikatz as some type of plugin for your remote access tool. That way you don't have to upload mimikatz.exe to the target. That's probably a really bad idea unless you're able to obfuscate it or pack it. Now let me copy this entire pass the hash command. We'll paste it in right here. Looks like it worked great. Now whenever you're using Mimikatz pass the hash, just because it actually forges the token does not mean the token actually works. We need to go ahead and try to use the token to ensure that it was generated properly and see if that password actually works. Now we've discussed this before, but Sliver actually doesn't have a steal token plugin, at least to my knowledge. So I'm gonna go ahead, grab the PID over here. We're gonna run an exit. And once we're back at the Sliver main menu here, we're gonna attempt to migrate into that new target process that Mimikatz started, and then we can inherit the credential of that process. So I'm back at the menu here. We're gonna run migrate. Let's do a help migrate. We'll see how to run it real quick. Looks like it's a TAC P PID, so we'll do TAC P. And then, like I said, 5072 right up there. Let it do its thing right here. Excellent. Successfully migrated, new session. I'm gonna go ahead, let's background sessions, TAC I for interact, and we're gonna interact with that new session that came in. Everything looks like it's working great. Now we can attempt to interact with our parent domain controller. Now, if you remember, I copied the host name from a prior DS query, and I saved it to my playbook here, so we don't need to rerun any queries at all. Here it is right here. We'll copy that host name. We'll double up all our backslashes. We're gonna try to list out the $C share. It worked great. We just confirmed that Kara's basic user account also shares the same exact password as her enterprise admin account. Now, that typically happens because users don't have a good way to manage their passwords. So rather than memorizing a brand new password, they just use the same password everywhere. This may be more convenient, but it is a bad idea. And if you're ever doing any type of red team assessment, I would say typically the weakest link is always users. So go look, see if you can find user accounts that match up, try to replay those credentials. This is a great finding that we would actually include in any type of report to Cyber Inc. saying, hey, some of your users share the same passwords. You need to do better user password education or get some type of password manager set up for your users so they'll use unique passwords everywhere. Now we can go ahead and jump to this target domain controller. Now, kind of like with our Chicago domain controller, we mentioned people do not surf the internet from these machines. So typically there's different firewall rules put into place or other type of monitoring looking for any type of malicious activity. So we're going to go ahead and generate a fresh TCP pivot. So the target CyberInk domain controller will actually pivot link back to the Chicago domain controller, which is also connected and pivoting back through our initial Phyllis Snyder workstation. So you can see here, the deeper you work your way into the network, you may have multiple sessions actually chained together throughout the network. That way, a network defender's only chance of seeing actual traffic coming out of the network is that original specific workstation. So to do this with Sliver, we're gonna do a help pivots. We wanna use a TCP pivot right here. So we're gonna do help pivots TCP. And it gives us a little bit more info, start TCP pivot listener port. So we're gonna do pivots TCP, TAC L right here. And then we need to give it a random port. Let's give it something that's relatively high so it kind of blends in. So then let's go ahead and check on that. Looks like we have our one pivot listed here with a bind address of 4532. That means our CyberInk target domain controller is actually gonna call back to our Chicago domain controller on this port right here, 45,342. Now there is one more step we have to accomplish. We have to generate a new Sliver payload that's gonna call back to our Chicago domain controller on that port. To do that, we do need our IP address of our domain controller right here. So it looks like our IP address right here. It does look like it has another network interface card, but nothing's hooked up to it, so that's okay. So we're gonna do a generate TCP pivot. And then we're gonna give it this address right here because we want it to call back to the Chicago domain controller. So we're gonna do 192.170.10.10 colon, and then we actually need to feed it our bind address right here. Great, it's generating now, shouldn't take too long. Now, one thing I always like to do before I ever trust something like this is to go ahead and perform a netstat to see if that port is open and listening, or more specifically, is bound to the correct interface. So let's do a shell, yes, cmd exe, netstat, anop tcp. And sure enough, we have our port open right here. And just like I wanted, it is open on all interfaces. 0.0.0.0 means it's listening on everything for any traffic to port 45.342. So we are good to go there. Let's go ahead and exit our little shell. So now I'm gonna scroll up and grab the Sliver implant payload we just created up here. I'm gonna copy it over to my playbook so we can start to build our upload command. Upload, paste. And then we wanna find a place to upload it to on the target that's relatively stealthy. So I'm gonna go ahead and grab that host name, which was right here. We're gonna copy, paste our clipboard, $, Windows, System32. And kind of like I taught you before, just pick a random letter. Let's do I start. And we can find any type of DLL we wanna blend in next to. Let's try this one right here. Our pastable's starting to come alive a little bit here. I'm gonna go ahead and grab this path that I just used right here, just so we can for sure make sure everything is spelled correctly. So there's my path. I'm gonna add in the DLL, and then we're gonna flip the extension to an exe because we're uploading an executable to the target. Excellent. So now we have our full upload command ready. We are going to be uploading this broad childhood executable, which this is actually the reverse TCP connection that's going to call back to our Chicago domain controller. And we're going to upload it to the path right here, CyberDC1, CyberInk local, all the way down to the executable here. So let's copy that, get to the bottom of our session. We'll do a paste, fire it off. Great, now our file is uploaded to this target right here. Now all we need to do is remotely execute the file. Now you could go to the RTFM. We have a ton of different remote execute plugins. I'm gonna go ahead and use WMIC to remotely execute our payload using the process call create function. To do that, I'm gonna open up a shell, cmd exe, and then I actually need to get the IP address to make sure WMIC works appropriately. So we're gonna do an ns lookup, and then I'm going to paste in the fully qualified domain controller name here, and we get our IP address just fine here. Now we can do a wmic node, paste in this IP right here, process call create, and then we need to give it the full path to the target executable. So we'll do C Windows System32, IRI exe. Make special note here, the path I'm giving it is in its own perspective. I'm not gonna pass in its $share here. This does have to be the local path of how that file exists and is seen from its own perspective. And then we should get back, I believe it's a result 0 if it worked appropriately. You may get some other things back if the path doesn't exist or the credentials are invalid. But we couldn't ask for better than this. Return value equals 0, and then we just got a new session from the target parent domain controller. We'll get back to the main sliver menu here, and then we'll interact with this new session. Background, session, tac I, sessions, tac I, whoops. And then again, I'm gonna do my PS, make sure I can see everything. It is worth noting, this is the executable I executed on the target. This does stand out a bit, right? Kara Vasquez is running one process among an entire system of system processes. She's not actually logged in. So if it were me, I would go ahead and migrate over to some system process. That way I would better blend in, but we're gonna keep running with Kara so we can compromise the next domain controller. So typically when you gain access to a system, you're gonna flip over to the situational awareness section of the RTFM. You're gonna go through your process list, your netstat, your IP config. You're gonna look all over the files on the system as well to look for any type of user profile directories, anything that could be of interest. At this point though, I'm gonna stay focused. Our goal is to get to the Huntsville domain controller. Now we are kind of lucky, now that we're at the parent domain controller, typically those enterprise admins have access to child domain controllers, so we should be able to use this same enterprise admin account to compromise the Huntsville domain controller. Now flipping back to my playbook here, I do want that DS query that enumerates trusts. We see Huntsville and Chicago, both the trust direction of 3. Now we have actual connectivity to the Huntsville domain controller. So again, let's jump back to our playbook. We're gonna change the target domain to Huntsville here. We're gonna dump all the computers and important attributes in Huntsville. Now this is a great example. I'm glad this happened. Kara does have access to the Huntsville domain. However, whenever you're doing any type of remote execution, sometimes you'll get dropped in with some token or some credential that just isn't set up properly. You'll have access to the system, but using that token to access other remote systems, you may get errors just like this. The operation being requested was not performed because the user has not been authenticated. So what I'm gonna do here, I'm gonna go ahead and get system on the parent domain controller, then we're gonna try that DS query again. And a great way to do this is actually service manipulation. So I'm gonna do this really quickly here. scconfig, VSS, bin path equals, and then we'll do C, Windows, System32. And then I do need to grab the executable we used. So let me bounce back to my playbook. Excellent. We'll paste in the clipboard. And this is not a service binary. And because I'm going quick here, I'm gonna go ahead and do a cmd.exe whack-c start whack-b. I've mentioned this before, but this is a quick workaround that allows us to use a regular executable with a service. So cmd whack-c start whack-b, C Windows System32, put our name in there, error equals ignore so it doesn't log that it's gonna fail, sc start VSS. Awesome, new session as system, that's exactly what we want here. And then we just need to make sure that we set it back. scconfig VSS bin path equals C Windows System32 vssvc.exe. I've got that one memorized at this point. Error equals normal. I'm gonna go ahead and do a QC just to make sure everything looks good. It was set back correctly. Now we can exit, go back to the sliver session and interact with our new callback here. We'll do a sessions tac I, do a PS, and awesome, you know, we have access, everything's looking good, it's working for us. As you can see, Kara Vasquez does still have this other session, but now we are running as system. Let's go ahead, let's be good little operators here. And we're gonna do a task kill whack pid. We're we're going to grab the old process, whack F. Went ahead, killed it. We'll exit out here. And then once we get back to the main sliver session, I'm going to do another PS and make sure that old process was cleaned up appropriately. And again, this is just utilizing good red team tradecraft. We're just minimizing our footprint on this host. So if someone were to get on there and do a process list, they don't see 5 different sliver sessions running, calling back to our infrastructure. So we're going to do a PS here. It looks a lot better. I'm happy with that. Now we can do our shell, cmd exe, and we can grab that original ds query command we were trying to run from the get-go. So let's grab that, paste our clipboard. Great, we got all of our systems back. There are a ton of workstations. Looks like some DevOps machines. Those could be important in the future as we're trying to gain access to some development resources. We also have this Huntsville domain controller, which we definitely want to gain access to. So let me copy back all these systems here. We'll throw them in a fresh notepad. And we'll definitely be using this data going forward. At this point, like I said, Kara's EA account should work to get to Huntsville. So let's go ahead and do our Mimikatz, pass the hash, generate a new token with Kara's account. Then we'll migrate into that process, and then we'll try to gain access to this Huntsville domain controller. So I'm gonna get back to the main sliver session. We do need to upload that mimi.exe, so let's do that first. So we're gonna do upload, paste in our Mimikatz path to our executable, and just like before, we're just gonna make it easy, put it in the root of C as mimi.exe. And with it uploaded, let's do a quick check here. We'll do m star. Sure enough, we have mimi.exe uploaded successfully. Now that we have Mimikatz up there, let's go ahead, drop into a shell, cmd.exe. And lucky for us, we can run literally the same Mimikatz command we ran last time. That's why we keep our playbooks. So we're gonna go ahead and fire that off. This should generate a token. Again, Kara Vasquez EA, CyberInk domain. Looks like it worked successfully. We're gonna go ahead and inject ourselves into this PID. So we're gonna do exit, exit, copy the PID right here. Then we're gonna run migrate, tac P, paste in our PID, migrating into. Successfully migrated, new session, sessions tac I. We can also see our full chain here. Check this out. We have Phyllis Snyder going to our Chicago domain controller, going to our Cyber DC1 right there. Let's do our PS, make sure everything looks good. Awesome, we were able to list out processes. Now we cross our fingers and we see if we can touch the Huntsville domain controller. I'm trying to think, did we have that in one of our pastables? Yeah, right here. We have our domain controller for Huntsville Hunt DC1. Let's grab the fully qualified domain name, add in all of our backslashes. We'll do a $C list. Couldn't ask for better than that. We have access to Huntsville DC1 CyberInk domain controller. So now we actually have to create another pivot listener, create a new pivot payload that calls back to the parent domain controller, upload it to the Huntsville domain controller, and then finally we're gonna execute it with sc.exe. So let's go ahead, let's get a playbook started. That way I can just fly through this stuff. So first thing we need to do here is pivots TCP. Now I'm gonna do a little help command here because I can never remember my syntax. So pivots, TCP, tac L for listening port. And then we're gonna do a port number. Again, I like to do just some random high port. So we'll do 55,428. Started TCP pivot listener. We're gonna do pivots. Looks like it's listening properly. Now that our pivot listener is set up and listening, I do have our prior generate command right here. As you'll remember, it was calling back to the other DC. We do need to do an if config to make sure we get our IP address for this parent domain controller. And then we need to do our generate command and make sure we add the correct port and the correct IP address. So let's backspace, we'll grab our IP address right here. And then we need our port, which is 55,428. We'll generate that, let that create our new payload, and then we need to upload it to the Huntsville domain controller in the C Windows System32 folder. We could find a place to blend it in. I'm gonna do something probably not very good. I'm just gonna reuse our whups.exe file name we used previously. But again, do not give your defenders a chance to find one file name and then search it over the whole domain. Try to use different file names as you can. We have our implant saved. Let's go ahead and copy it right here. We got to put our upload at the beginning, so we'll do upload. And then we need our target domain controller path. So we're going to come back over here, grab our fully qualified domain name. And then we need to make sure we get all of our backslashes set up here. $, Windows, System32, whoops.exe. We'll copy that. We'll paste it in here. And then let's just do a quick walkthrough. We're going to upload the new implant we just created, 4 backslashes, to Huntsville Domain Controller 1, Huntsville Cyber Inc. Local, $, Windows, System32, whoops.exe. Everything looks good. My backslashes look good. Let's fire that one off. Looks like it's uploading successfully here. Hopefully it works. We're going to do a little validation to make sure it works once it finishes up. Awesome. Looks like the file wrote out successfully. I'm going to grab the path and we're actually going to do a fresh ls. Sure enough, our payload whoops.exe right here. Looks good, blends in. And now we're going to execute our service manipulation remote execution technique. I already covered this in a previous video, so I'm going to go pretty quick here. But if you want to check it out, go back to that video. It'll definitely make more sense. I'm a big fan of making a playbook for this one just because there are so many steps. So I'm going to do SC hostname QC VSS. This will give me the original bin path. Then I'm going to do SC config VSS. We'll change the bin path to C Windows System32 whoops.exe. I do need to do the cmd.exe start whack B because this is not a service binary. I do cover that in that previous video, how to get a service binary. That way you don't have to do that. We'll do error equals ignore. Then we need to do SC. Let's grab the fully qualified domain name. We need to actually start the service. That's important, right? Then we can go ahead and change the bin path back to vsssvc.exe. With our playbook in place, now we can start executing it from top to bottom. Again, please make sure you're reading your output just to make sure if something fails, you'll definitely see it. So we're going to start a new shell, cmd.exe. Let's do a little task list, make sure we're good. We're going to paste in our QC VSS. We have our original bin path here. We're going to grab our SC bin path change right here, paste that clipboard in. Looks like it was successful. Let's go ahead, fire off that service binary. We got our new session. That means it worked properly. That reverse TCP connection connected back thoroughly. Again, check it out. We have Phyllis Snyder calling to Chicago, calling to the parent Cyber Inc., and then finally to our target Huntsville's domain controller. We are chained through 4 separate machines through the network now, so definitely building up a lot. Let's not forget to set back our bin path just so we have that working. We're going to change the error to normal. And then let's do a final SCQC just to make sure that that bin path got set back. We're good to go. Now let's go interact with our new session. We're going to do an exit to go back to that original Sliver dashboard. And then let's go find our new session ID, sessions, tac I, paste it in, do PS. Great, whoops.exe, looks good there. I'm going to go down into a shell, and let's do a host name. We'll make sure, yep. Hunt DC1, exactly what I expected here. Now, take a deep breath. We've finally made it to the Huntsville domain controller, but there is one more big step we have to make to further our mission in this domain, and that is to find Brian Leon's workstation. Now, we're gonna kind of shortcut things a little bit. We're not gonna necessarily do the user hunting, but I did wanna show you another quick way we can try to locate a user that's logged into a specific workstation. First things first, let's get a little bit more information about Brian Leon here. So we're gonna do an object class filter. We're gonna do name equals star, Leon star. We're gonna print out the attributes, Sam account name, name. Let's fire that one off. And perfect, we got Brian Leon right here. So we know this is his name. So we're gonna do another DS query star, tech filter. But now that we have his name, we can just do name equals Brian Leon directly, and then I want everything. Give me everything you have about Brian Leon. This is a really good sign. He's a part of the development admins Windows Active Directory group. This means if I gain access to his workstation, there's a great chance that I'll get access to any type of source code and other development work he does. If you recall from our previous DS query enumeration, let me click back here. We saw two specific workstations that were doing development operations. So let's create a new folder. We'll paste both those names here. We have DevOps 3 and DevOps 2. Now I'm gonna make an assumption here. I'm gonna assume that developers have some type of local administrative access to their own workstation since they're installing different development tools, plugins, stuff like that. So we're actually gonna generate a token as Brian Leon. Remember, we're on the Huntsville domain controller. We have all those hashes. So we're gonna do a DC sync, Brian Leon, take his cred, create a new process, migrate to that process, and then attempt to list out what's on these two workstations. Playbooks are great. I'm gonna come back here to exactly what we did with our DC sync and our pass the hash. And we're gonna create this new playbook here. So we get ready. Let's exit, go back to the main Mimikatz menu because I do need to upload that Mimikatz exe again. Let's do upload, paste clipboard, C, mimi.exe. Awesome, looks like it's uploaded successfully. Now let's go back to our playbook. We're gonna do our DC sync again. The domain though, this time let's do Huntsville, CyberInk local, DC sync looks good. User is actually gonna be Brian Leon. And I can scroll up here if we can get his exact name here. It does have to match his exact same account name, which he uses to log into Windows. So this looks good here. Let's come back, jump down into a shell, cmd exe, paste the clipboard. Great, we got his specific hash for Windows. Copy that back to our playbook here. I already pre-copied our pass the hash command right here. And then it's just a little bit of find and replace, right? Change out the hash. The username does need to be Brian Leon. The domain is Huntsville. We'll copy that whole thing. Make sure we're do our exit in our Mimikatz session. We'll paste it in here. Great, we got a new process identifier. It looks like it worked correctly, but again, we have to validate it. So let's exit, exit. We'll go back to our sliver session, attempt to migrate into this process here. So we'll do a migrate, tac P, put in our process here. Great, we migrated to that process. Now we should have that Brian Leon token loaded into this specific session. So let's do a background. We'll do a sessions, tac I, jump into that session. So now that we have the session and Brian Leon's token, let's do a shell, yes, cmd exe. And now we can take a little bit of a peek against those two DevOps machines and see which ones actually have users logged in. So let's grab our host name over here, and then we're gonna do that with task list whack v, whack s. This is going to verbosely enumerate processes on the target DevOps 3 computer. So we're gonna go ahead and run that. Let's see what comes back. And we didn't really get anything back. It looks like it's just kind of stuck here, which again, red team tools are not the most feature filled. I tried to run this task list. It's obviously stuck or failed. I'm guessing this target machine, DevOps 03, probably isn't on or isn't up. You're gonna run across this stuff all the time in real world ops. In this instance, I'm just gonna Control C. We're gonna rerun the Sliver client here, do our sessions, and then our sessions tac I. We're gonna interact with that session that had his token. Again, we're gonna do shell, cmd exe, so we can get all ready here. We'll do task list just to make sure our session's up and running. Everything looks good. So now let's try to do a task list, whack v, whack s, but let's target that other workstation. I think it was DevOps 02. Let's run that one and see if it actually responds. We got a response. These are all the processes listed out on that target workstation. And what do you know, right here, Brian Leon is actively logged onto that machine. So that's an easy way we can kind of take a quick peek against a target machine and see if there's a user actually logged in. Now that's a scenario video, right? We started out in Chicago, we moved up to CyberInk, we moved down to the Huntsville domain controller. We specifically honed in on Brian Leon's machine. From there, we know we have credentials because we did a remote task list of that target machine. We saw Brian Leon actively logged in, doing his job. That's the end of this scenario video. However, if you click through to the next video, you're gonna keep watching the scenario unfold as we gain access to Brian's box, data mine his machine, and potentially find a path to a specific Linux machine. From there, you can flip over to the Linux section of the RTFM, and we're gonna go through situational awareness, file system information, all sorts of really awesome things about Linux. So flip through to the next video, let's further this scenario and see if we can gain access to a Linux machine.